Can torpedoes turn around and chase down the sub that launched it? Absolutely they can, which is why modern torpedoes have safeties that prevent this from happening. They are computer-controlled and can be set to self-disarm should they deviate from their programmed course. In World War II, it was a very big concern. Several subs are thought or known to have been lost due to circular running torpedoes. One famous submarine that did kill itself was the USS Tang. In 1944, she was attacking a Japanese convoy in the Formosa Strait when no sooner than the last torpedo left the tube, it looped back and detonated on impact with her stern. The blast nearly blew off the stern and instantly killed everyone in the aft compartments. She sank immediately in 180 feet of water and was then depth-charged by the escorts while flooding progressed rapidly through the boat. Most of the crew perished, but the captain and some of the crew managed to escape the sunken submarine to be immediately captured by the Japanese. There is also a German U-boat off the east coast of the US that was obviously the victim of one of its own torpedoes looping back at it. Another suspected instance was the USS Scorpion. There is a possible clue at the wreck site that shows she was heading east, not west as she was supposed to. Scorpion was on the way to her home port, which leads some in the Navy to suspect one of her Mk-37 torpedoes had a hot run, which is an unintended activation while in the tube or in one of the racks. These weapons had a tendency to explode if the hot run was not stopped immediately, and torpedoes have a mechanism that shuts them down if they loop back at the submarine. There has been speculation that she reversed course in an effort to shut down a hot-running torpedo which detonated and sunk the Scorpion. Continuing this list, we can also recall the sinking of the submarine Kursk. Along with the official and extremely nonsensical version of the peroxide torpedo explosion, another version appeared. Kursk fired a supercavitating torpedo, Squall. As is known, the Squall torpedo develops a tremendous speed, about 6 times higher than the fastest modern torpedoes and, according to various sources, 200 knots. After launching, the torpedo turned around for some unknown reason and hit the submarine that fired it. In general, a torpedo with a rocket engine and a cavitation head, which ensured water boiling around the warhead and thus ensured torpedo movement in a gas cloud rather than in water, has its major disadvantages. The fact that the thickness of the cavitation bubble, which reduces water resistance, is quite small, and maneuvering the torpedo in the usual modern sense is impossible simply because, when turning, part of the torpedo hull falls out of the bubble and meets the very water resistance from which it tried to get rid of, and this instantly puts it out of action. In addition, modern torpedoes have homing systems that use a combination of active and passive sonar, but the cavitation process itself creates such an eerie background that the sonars are simply useless. These two factors combined mean that the torpedo is virtually uncontrollable and is fired in a straight line. The maximum that it can perform, different from a straight line, a very gentle arc, but even the arc it does not need. It simply does not have the ability to point at something because the sonars are simply dead. For this reason, at the very beginning of development in the 60s, it was assumed that the torpedo was fired in the approximate direction of the target and detonated at some distance from it. The target is not struck by a direct hit, but by the energy of a nuclear explosion that occurs close to the target. But from this, it follows that the Kursk Squall could not physically target not only the mother submarine, but anything at all. Moreover, it has no physical possibility to make such a turn to return to the starting point. Hence, the conclusion. The Russians have carefully concealed some option, which may prove more shameful than anything that has been said up to this point.